Hello there, Math 126 students. Somebody's asking me a follow-up question on surface of motion. And so I just wanted to recap. I do have a lot of resources on this. This particular one said, so here's this particle moving around. I'm graphing it here. Just seeing it moving around, I feel like makes it hard for me to think about. So could I say anything about where that particle is? That's what a question like this is about. So the question says that it's on a plane. Well, that's helpful. But anyways, it tells me the following, that this is cosine of t plus 1, that y is 4 cosine of t plus 2, and that z equals 5 sine of t plus 7. So we talked about our two techniques to eliminate the parameter. One of the techniques is to solve for cosine, solve for sine, and realize that this squared plus this squared equals 1, and that's what one student's asking about. You could definitely do that here and see what happens, but the question is asking for a plane. So if this doesn't lead to a plane, then we haven't answered the question. It is possible to do this here because I have cosine and I have sine. So I can solve for cosine. This cosine is equal to x minus 1 over 3. This cosine is equal to y minus 2 over 4. And this sine is equal to, and this isn't the way to answer the question, but I'm answering a student question first. So what can we say? Well, we can say two things immediately. One thing we can say is that, let's write it here, x minus 1 over 3 squared plus z minus 7 over 5 squared equals 1. That's putting those two together. Those two together. That's actually an elliptical cylinder. Let's take a look. Here it is. That cylinder. So the object is moving around that cylinder. It doesn't mean that the motion in the cylinder are the same. It just means that every point on the curve is on that cylinder. In fact, the curve looks like this if I trace it out. All right, that's kind of cool. But the question did not ask for a cylinder, it asked for a plane. So it is true that it's on that surface. What about if we combine the other two? That would be great. Y minus 2 over 4 squared plus z. And this was back when we were talking about how to visualize motion. That's another cylinder. It's this one. Ooh, that's pretty. So that's on the intersection of both of those. That doesn't mean it touches every point on the intersection, but again, this is all, the goal here is we're trying to understand that motion we had at the beginning. And this is just giving us information. You got to be on this cylinder. You got to be on this cylinder. The question didn't ask about either of those, though. The question asked about a plane. So is there anything we haven't combined yet? We combined those two. We combined these two. Oh, we haven't combined y and z. And look at, they're both cosine, sorry. So they have to be the same. So the last thing we can say is that x minus 1 over 3 equals y minus 2 over 4. That is indeed a plane. You can write it as a plane. You might say, where's the z? But the z is 0. It's this plane. So the motion is on that plane. The confusion the student was having was, what about the cylinders? It's also on the cylinders, just the question didn't ask about those. And together, that all gives me more information about where the curve is. In fact, a lot of the times the way we describe a curve is based off of what surfaces it's on. All right, I hope that answers that question. You can see a lot more in my previous videos on this, but I wanted to really hit that home. All right.